Okay, so last set of videos on study area number 3. I'm not doing study area number 2, yeah? So here we go, electrochemistry. Now, in electrochemistry, one of the most important thing is the SRP table, which will be given to you during the exam. So in the SRP table, you have to remember one thing, right? All aqueous solution, everything that is aqueous is 1 molar, okay? All gases are at 1 atmospheric pressure, and the temperatures is 25 degrees Celsius. All that you must know. So if the solution given to you is less than 1 molar, the voltage is going to be lower, total voltage will be lower. If the more than 1 molar is going to be higher, okay? So in our syllabus, we are calculating everything based on, everything calculated is based on 1 molar. So there is no need to calculate for less than 1 molar, right? Okay, here we go. In the SRP table, all of your equations are written in the reduction fashion. You see electrons here at the before the arrow, okay, before the arrow. So it means that it is reduction. That's why you call it the SRP table. As far as you are concerned, when you do electrolysis, this equation is very important for the reaction at cathode. Okay, cathode, which is negative. This is during electrolysis. Okay, now this reaction is important at anode during electrolysis, but this reaction has to be reversed. You have to reverse this equation when you write it at anode. Okay, you have to. So it's going to be like this. If you ask me this question one more time, I'll probably cry. Okay, so this is how your equation at anode should be written. So you have to change it. If you ever need to use it, you got to change it. This is water being oxidized at anode, and anode is positive. In electrolysis, anode is positive. Okay, so then you see everything else is written in this manner. So all you have to do is, when you're comparing two things, you just see look at the value. Okay, for example, right? For example, let's say we compare these two. Okay, let's compare these two, right? Okay. Now, between both of this, you will notice that this is a positive, more positive than stannum. All right. So this basically means this guy, aurum is a very good oxidant. Okay, so aurum, if there is a reaction between tin and aurum ion, aurum 1 will be the oxidant. He will volunteer to pick the electron up. So it's him who's going to pick the electrons up. And the other reaction, tin is the reductant. This is the guy who is going to be losing electrons. So when you write an equation, it's going to be aurum, you just leave it as it is. Do not disturb this. The top equation, you reverse it. That means you write it in this manner. Okay. And then this value also will be reversed. Okay. So you take this number and you plus with this number. This will give you the voltage that is produced by the cell. All right. So if Joel, you're listening to this, Joel has a different way of doing this. So, okay, Joel, you can do the way you want to do, but this is how I normally recommend. So at least you get your equations done up as well correctly. So, so in this case, what you will need to do is you got to make sure that the number of electrons lost and gained are the same. So this equation, you're going to multiply here with 2, and then you add the two things up. Please remember, when you multiply with 2, you do not multiply the voltages. Do not. Please remember, you do that, you get 0. Okay. So that is as simple as it gets. Right? So you just use this equation. And then sometimes you come across questions like, you see, when you do Voltaic cell, okay, let's say Voltaic cell, right? What happens is, sometimes you get a question where you have iron, okay? So you have a solution here, and then it tells you it's a mixture of Fe2 plus aqueous and Fe3 plus aqueous. The electrode that you're going to use, must be inert. Can be graphite or platinum. It cannot be iron. You cannot put iron inside. Why can't you put iron inside? Because if you put iron, what will happen is the iron will undergo oxidation. And this value will be positive 0.44 volts. Understand? And then what will happen is in the solution there is Fe3 plus, right? There is Fe3 plus. So the Fe3 plus will pick the electrons up and become Fe2 plus, and this will be positive 0.77. So what will happen is the Fe will react with the Fe3 plus straight away. So there is no electricity will be generated. Understand? Okay, there will be no electricity which will be generated. And then when you do electrolysis, let's say you have the electrodes here, right? Okay, let's say you have anode. Okay, anode is positive. Okay, so usually what happens is to the positive electrodes you get all the negative ions going. Let's say like you get bromide, and then there is always water. If it's aqueous solution, you're doing electrolysis of aqueous solution, you always have water. So anode is where oxidation is happening. So these guys are going to anode and hoping to be oxidized. This is what is happening. I'm giving you an example, okay? They are hoping to be oxidized. So your job is they're going to anode and hoping to be oxidized. So your job here is oh my god, suddenly I'm having a mental freeze. Okay, so water is undergoing oxidation, right? Water is undergoing oxidation. So what is going to happen is it's going to be oxygen plus 4 this plus 4 electrons, right? So for this one, I know the value here is negative 1.36 volts. This is negative 1.07 volts, and in this case this is negative 1.23 volts. Okay, your job is very simple. All you have to decide is which of these numbers is the least negative or the most positive, whichever. Least negative basically means more positive lah. So you notice in this case, right, very straightforward, because everything here is supposed to be 1 molar. Okay, so you notice in this case it is this. That's it. So what you will see at the electrode is you'll see is bromine being produced. So bromine, of course you cannot see bromine. So what you will see is you'll see a reddish brown liquid being formed around here. So we always choose the most positive. Please remember, I'm not going to repeat this again. Then meanwhile at cathode, again, if you're doing aqueous solutions, water will be going there hoping to be reduced, okay, to produce hydrogen gas and hydroxide. This is negative 0.83 volts. Let's say you have metals going there. Let's say zinc going to cathode to be reduced as well. Negative 0.76 volts. I remember somebody asked me this question. So let's say you also have iron. Let's say you have iron Fe2 plus going to the cathode to be reduced. They're all going there, okay, during electrolysis. Let's say you have a mixture. So your job again is very easy. You just have to choose the value which is least negative or most positive. So this is the answer. So what will happen here is Fe2 plus will become Fe. So what will happen is you'll see some solid forming over here. That will be Fe. And since this solution is green, this is green, right? So eventually what will happen is the color green, the solution becomes lighter. That's it. That's what you do for electrolysis. Okay, then that brings us to things like random things. Okay, let me just randomly talk to you. Okay, so let's say we talk about fuel cell. Okay, you have a fuel cell, right? Let's say you have a fuel cell. Generally all fuel cells look something like this. You have one electrode here, you have one electrode here, and then there's a power, there's a voltage or whatever it is. Okay, so you just got to remember, okay, let's say this one, okay, here, okay, so in every type of fuel cell, right, there is always 2 inlets and usually there's 1 outlet lah. Usually, okay, it does not matter. So one side is always the oxidant going in, and most of the time it's always oxygen. This is the oxidant, okay, oxidant. Here will be the reductant. So it can be anything. It can be hydrogen, it can be methane, it can be propane, it can be butane, right? It can be anything. It can be anything, even things that you have never seen. Like for example, let's say there's one question that we did recently. There was methanol. Okay, so they put methanol inside. Also can, not a problem. So what happens is, whenever you have any one of these guys, okay, these guys will always be converted. So this guy will be converted to hydrogen ion, this carbon dioxide, this carbon dioxide, this carbon dioxide, this carbon dioxide, and then your job is to write a balance equation. For example, let's say we pick methanol, right? CH3OH is going to become carbon dioxide. The question will tell you, so you're not supposed to memorize this. So your job now is to balance this equation. Okay, make sure the number of carbons are the same. Priority number one is all atoms except oxygen and hydrogen. So one carbon. Next one is oxygen. So there are one oxygen on my left here, two oxygens on my right. So what I'm going to do is I'm going to put a 2 over here. Oops. Oh, sorry, I made a mistake. Okay, so I'm going to put water here. Sorry, I'm going to put water. What am I saying? I'm going to put water here to balance the oxygen. Then I'm going to add hydrogen ions on this side to balance the hydrogen. So there is 2 here. There was 4 here. So there are 6 hydrogen ions here. Then I add 6 electrons to balance the charge. This is the oxidation half equation. Okay, and this happens where does this reaction happen? This happens at anode. Okay, and usually oxygen will be reduced to water. So basically you're going to be writing this equation where is it you'll be writing this equation here, this blue one here. This is what you'll be writing. So if you're going to write it from scratch, so basically what's happening is oxygen becoming water. Okay, so we balance the 2 oxygens on my left. What we're going to do is we're going to add another water here to balance the oxygen. Suddenly you realize there are 4 hydrogens on the right, so we're going to add 4 hydrogen ions here, and we're going to add 4 electrons. Okay, that's how we balance the equations, right? Please watch my videos on balancing half redox reactions, which is on Teams for those of you and my students, and on MLearn if you're not my student. Okay, so that's basically it. All right, so and then other things are like salt bridge. All right, so when you have salt bridge, please remember in salt bridge, N ions, all the negative ions, N ions will go to anode. Cat ions, all the positive ions will go to cathode. Okay, you got to remember that. All right, you got to remember that. So there is no equation that can be given to you which will throw you offline, like suddenly you don't know what's going on and so on. So those kind of questions, I think most of the questions you should be able to do. So like for example, sometimes you are asked to predict whether a reaction will happen or not. Okay, so let me just pick one question here. So let's say we want to predict whether this reaction happen or not. That's the question. Can this happen? Can this reaction happen? So very easy. You look at the SRP table. You look at this. You find this equation, right? Find this equation. So this, if I'm not mistaken, is negative 0.154. I could be wrong. Huh? Look it up. And then iodide becoming iodine, right? You look at this equation in the SRP table. This one, I think it's negative 0.54 volts. Okay, this one. Yeah, so when you add these two numbers up, you're going to get a negative value here, right? You're going to get 9 and you're going to get 0.69 volts. So this reaction will not happen. Okay, this reaction will not happen. So you got to find a reaction that will happen. That's it, as simple as that. All right, so like for example, in this case, let's say hydrogen ions plus, let's say, iron, you get Fe2 plus hydrogen gas. Okay, so what you do is you look at the SRP table. This is hydrogen ions, pick up electrons, 2 electrons, and become hydrogen. In the SRP table, this is 0.00 volts. Fe becoming Fe2 plus 2 electrons. This is positive 0.44. Obviously, if you add up the numbers, you get positive 0.44. So this reaction will happen. This reaction will not happen. So that's it. Okay, that's it. What else? Okay, so as far as that is concerned, I think that's more or less it. So in quantitative electrolysis, we have Q equals to IT. All right, and please remember T is again in seconds. All right, it's in seconds. And then the next thing you find is number of moles of electrons, which will be the Q that you have calculated divided with 96500 coulombs. Okay, so this will tell you the number of electrons which are running through the system. Okay, so once you find the Q, you do that. Once you know the number of moles of electrons, then it's easy for you to do calculations, right? So let's say, like, for example, if the number of moles of electrons is 0.025 moles, let's say, okay? So for this reaction, Fe plus 2 plus 2 electrons, you get Fe. Let's say Fe is 56 grams per molar, let's say, huh? So basically what I will do is I'll do a simple one. I said electrons and then mass, okay? So if 2 moles electrons, the mass is 56 grams. That means if it's 0.25 moles electrons, let's say 0.025 moles, how many grams will it be? So it's cross multiplying, am I right? Times 56 divided with 2. Simple. It's a very simple calculation, all right? Nothing complicated about this. The way I look at it, most of the questions are pretty straightforward. Pretty straightforward, okay? Yeah, that's it. I think that's about it. I think for study area 3, I don't think there's anything much here that I want to do with you. There was one question that where what they did was they gave you two solutions. And then the concentration of the solutions here was 0.1 molar. All right. So in both cases, the concentration given to you was 0.1 molar. So obviously, when you calculate the voltage, right? When you calculate the voltage, it's not going to be the standard voltage, because the molarity is lower. Because this molarity is supposed to be 1 molar, then we can use the SRP value. Okay, so it's going to be lower than what is supposed to be. So please remember that. Okay, doc. I think that's about it, and you guys are most welcome. You're most welcome to. I think I've given you all enough videos, enough things to see, and to last you a lifetime. Okay, good night. Wish you all the best for your exams. I'm not going to be recording any videos for study area number 2 because we just did the revision recently, and those of you not in my class, your teachers did revision with you as well. Okay, doc. So wish you all the best for your exams. Take care. Bye bye.